Welcome back to Statics Lectures by Civil Thinking, and today we are going to see another concept. Now before I move on, I suggest you to please watch the video lectures in sequence as in the playlist so that you can understand better. Now the playlist link, you can find the link in the description or also you can click on the pop-up on your screen. Now coming to the today's concept, today we will see Varignons theorem, concept and example problems. Now the contents in this video lecture which I am going to cover is Varignons theorem, concept and example problem, resultant of non-parallel non-concurrent force system using Varignons theorem with example. Alright, now we will see what is Varignons theorem and we will solve some problems on Varignons theorem, because Varignons theorem also help us to find the resultant of non-parallel non-concurrent force system. Now let's move on. Now the first is, what is Varignons theorem? Now the moment due to force at a given point is equal to moment of components of that force about that point. This theorem is useful when we are not able to find moment of a force about a point, but moment of its components about that point is easy. Now this theorem also helps us to find exact location of resultant vector. Now let me tell you what it is. Now Varignons theorem says moment of a force about a point, it is equal to moment of components of that force about that point. Now what does it mean? Now for example, let us say you have a body something like this, okay, and a force is acting here, F, okay. Now this is the point A. Now movement of this force about point A, okay. Now let us say this is the line of action of this force, okay. Excuse my handwriting, it's a straight line, okay. Now movement of this force F about A is what? Moment about point A is equal to force multiplied by perpendicular distance. Now the perpendicular distance of F force about A point is this, right? Let us say this is X, okay. So moment of this F force about A is F multiplied by X. Now sometimes what happens is that we don't know the value of X. We don't know how far is F normally from A. In short, we don't know what's the exact value of X, or it is very hard to find the value of X. But we need to find the moment of F force about A. So what we can do, we can let us find the resolve this force F about X axis and Y axis. Now let us say this is F cos theta. This is the X component of F force, okay. This is X axis and this is Y axis. This is F cos theta and this is F sin theta, right? I am resolving F force in two normal components, F cos theta and F sin theta. This is known as resolution of vectors, okay, resolving a force about two rectangular components. Now if you don't know much about this, you can watch the video lecture on resolution of forces or resolution of vectors, okay. It is quite simple. So let us say we know this distance. For example, this is 3 meters and here we have it is 4 meters, right? Now we have to find the moment of F force about A, but we don't know X. So Moment of F force about A is moment of components of F force, which is F cos theta and F sin theta, about A. Okay, now it is F cos theta multiplied by, now how much is F cos theta normally far from A? Now you can see the normal distance between F cos theta and A is this, right? This much, and it is 3 meters, so it is F cos theta multiplied by 3. Okay, I am assuming clockwise movements to be positive and anti-clockwise movements to be negative. Now F sin theta is this, and F sin theta is normally at a distance of 4 meters from A, right? So it is, but this F sin theta will exert anti-clockwise movement, so I will write negative here, F sin theta multiplied by 4, right? Now this is Varignons theorem. All of this is Varignons theorem, right? Now I hope you get the concept, what it is saying. According to Varignons theorem, moment of force about a point is equal to moment of components of that force about that point, right? The point has to be same point, right? It has to be the same point, then the moment of the force is equal to moment of its components about same point. Okay, that is Varignons theorem. Now how did we solve our problem? You see, initially x was unknown, but when we find the moment due to components, which is f cos theta multiplied by 3 and f sin theta multiplied by 4, we don't need x here, right? As you can see, there is no x right here, right? There is no x here. Basically the moment was f multiplied by x, right? But we found due to components, it is f cos theta multiplied by 3 minus f sin theta multiplied by 4. Now if we know the value of f and the theta, we will find the moment of A about moment of force F about point A, right? Don't worry, I will solve this exactly the same problem in a clear way as we move ahead. So let's move on. Now there is another point. This theorem also helps us to find the exact location of resultant vector. Okay, you know, you see this line, this statement, you will understand this with the help of an example which I will solve at the end of this video lecture. Okay, so let's move on. Now here is the same problem. Find the moment of force F about point A in the figure. Now this is the red, as you can see in the red color, this is a force. This is a rectangular body. The breadth of this rectangle is 3 meters and the length is 4 meters. This is force F, which is 20 kilonewton, which is inclined at an angle of 45 degrees with the horizontal, or you can say it is x-axis. We had to find the moment of this force about A, right? Now as a basic rule, we know moment is equal to magnitude of force multiplied by perpendicular distance, right? So if you want to find the moment of this force about A, we have to find the magnitude, which is 20, and the perpendicular distance of this force about A. So let us assume this is the line of action. Now this is the line of action of this force, and the perpendicular distance of force F is something like here, right? Is something like here, right? But we don't know the distance between F force and A, right? Let us say this is X. So we would say moment of this force is F multiplied by X, but we don't know X. So what we are going to do, we will resolve F force, 20 kilonewton force, into X. Let us say this is X axis, horizontal axis like this. This is X axis and this is Y axis, okay? This is Y axis and this is X axis. When I resolve this 20 kilonewton about X axis, it is going to be like this. F cos theta theta is 45 and this is f sine theta, right? Now, so the moment is f cos theta multiplied by, how far is f cos theta normally from A? Now here is A, you can see like A is in this, it's like in this line, right? A is here. So the distance of f cos theta is from here to here, right? Which is 3 meters, right? This is 3 meters. So it is f cos theta multiplied by 3, right? Now the f cos theta will exert a moment like this, clockwise, right? If you don't know how it is going to exert clockwise moment at this point, please comment. It is simple. The force, you can see that this force is going to exert moment like this, right? So it is clockwise. Now we found the moment due to this component, x component. Now let's see the moment due to y component. Y component is f sine theta. Now f sine theta is here, and it is, how far is f sine theta normally from A? The normal distance between f sine theta and point A is this, right? How much is it? Now this is 4 meters from here to here. It means this is 4 meters too, right? Now f sine theta is going to exert anti-clockwise moment, right? So it is minus f sine theta multiplied by 4, right? Now how much is f cos theta? Let us find the value of f cos theta. Now f is 20, f cos theta, and we will see how much is f sine theta, right? F sine theta. F cos theta is, now f is 20 kilonewton multiplied by cos 45 degrees, right? And f is 20 kilonewton sine of theta. Theta is 45 degrees. Okay, now let me use a calculator to find the value of these two. Okay, f cos theta is 10 multiplied by under root of 2, and f sine theta is 10 root 2. Okay, now the value of both f cos theta and f sine theta is 10 root 2. Now f cos theta is 10 root 2 and f sine theta is 10 under root of 2, right? Now when you solve this equation using calculator, let me use a calculator. It is negative 10 root 2. Okay, so here we found the moment of F force, which was otherwise very difficult. Now with the help of Varignons theorem, because we found the moment due to components, which was very easy to find, we found the moment negative 10 root 2. Now what does this negative mean? Now we know clockwise movements are positive, right? And anti-clockwise movements are negative, right? Now since it's negative, it means the moment of the force F at point A is negative, right? Means anti-clockwise, something like this, right? So I hope you understand this concept. If you have any doubts, please comment, and let's move on. Now, resultant of non-parallel non-concurrent force system using Varignons theorem. Now, in previous classes, we have found resultant of different force systems, and I had already told you that we will find the resultant of non-parallel non-concurrent force system after going through Varignons theorem. If you have not seen that lecture, please click on the pop-up on your screen to watch that video lecture. Now, non-parallel non-concurrent force system is something where the forces are neither parallel and they are also not concurrent. Okay, now the best example is here. As you can see, this force system, the forces are not parallel, right? This force is like in the x direction, this is in the y direction, so they are not parallel. Also, they are not at the same point. This 20 kilonewton is at point D, this 4 kilonewton is at point A, 10 kilonewton is at point B, Now let us say this point is C. 16 kilonewton is at point C, right? They are not at the same point, which means they are not concurrent. Now we have to make some assumptions to solve this problem. Now, number one is sign convention. Let's assume the x-axis force towards right. As you can see here, it is positive, and the force in the y-axis which are upwards, they are also positive, okay? And other forces which are opposed to them, they are negative. So this is assumption one, is this. The second assumption is, let us assume the clockwise movements to be positive and anti-clockwise movements to be negative, okay? The third assumption is forces are concurrent. Forces are concurrent, okay? Now, as you can see here, these forces, they are acting at different points, right? This 4 kilonewton is at A, then we have force at B, we have force at C. We will assume all of these forces to be acting at a single point. This is an assumption, okay? After assumption, we will find the exact location of the force, okay? Forces. Now, let's assume the forces at this point, the center point, okay? Now, when we assume the forces are concurrent, then we will find the resultant using method of projections. Method of projections. With the help of method of projections, we will find the resultant of concurrent force system. Okay. Now, I have already made a video lecture on how to find the resultant of concurrent force system using method of projections. If you have not seen that lecture, please click on the pop-up on your screen. Now, it's very easy. Now, in the method of projections, we find summation of forces in the x direction and the summation of forces in the x direction, okay, in the y direction. So let's first find sum of all the forces in x direction. It is now 16 kilonewton is in x direction. It is towards right, so it is positive because towards right is positive. 4 kilonewton is x-axis, is along the x-axis, and it is towards left, which is negative. So the summation of all the forces in x direction is 16 minus 4, right? 16 minus 4 kilonewton, which is 12 kilonewton. Similarly, we will find summation of all the forces in y direction. Now in y direction, we have 20 kilonewton and 10 kilonewton. Now 20 is upwards, so it is positive. 10 is downwards, so it is negative. So the net force along y-axis is 20 minus 10, which is 10 kilonewton, okay? Now the magnitude of resultant is whole under root of summation of fx square plus summation of f of y square, right? So it is whole under root of summation of f of x square is 12 square plus it is summation of y is 10, it is 10 square. So let me use the calculator. It is approximately 15.62 kilonewton. 15.62 kilonewton, okay? Now we have the resultant here. It is 15.62 kilonewton, right? Now if you remember, this was summation of f of x, right? Summation of f of x was 12 and summation of f of y was like this. Summation of f of y is 10, right? Now let us find this angle theta, the resultant with the angle of resultant with the horizontal. So it will be found using theta is tan inverse of summation of f of y divided by summation of f of x, which is tan inverse of summation of f of y is 10 and summation of f of x is 12. So it is approximately 39.8 degrees. 39.8 degrees. Okay, so this angle, the resultant is making an angle of 39.8 degree with the horizontal. Okay, now this is the resultant magnitude and we find the angle now, but we don't know the exact location of the resultant. Initially we assume the forces are concurrent at this point, this center point, but and because of that the resultant is here, right? But it is just an assumption. We don't know where is the resultant. It may be here, it may be here. Wherever it is, the resultant magnitude will be 15.62. The angle with the horizontal will be 39.8 degrees wherever it is. So right now we have to find the exact location of the resultant. Okay, so let's make an assumption. Okay, now let's change the color. Let's assume the force is, the resultant force is at a distance of x from what? From point D. Okay, now we don't know the value of x, so we will use the Varignons theorem to find the value of x. Okay, so let me first erase all of this. We'll find moment of resultant r about D. Okay, moment of resultant about point D is equal to moment of all the forces, because this resultant is because of these forces, right? So the moment of resultant about point D is equal to moment of all these forces about point D, right? Moment of resultant about point D, it is anti-clockwise, right? So I will write negative R is 15.62 multiplied by X, right? This is the moment of resultant about point D. It is equal to moment of all the forces about point D. Now 16 kilonewton is passing through point D, as you can see. So moment of 16 about point D is 0. So we will not consider 16. Now also 20 is passing through D. So moment of 20 about point D is 0. So we will also not consider this. So we will be only considering moment of 10, which is at a distance of 4 centimeter from normally from D, right? And we will also find the moment of 4 Newton from point D, which is at a distance of, which is at a normal distance of 3 centimeter from point D, right? So now 10 kilonewton is going to exert moment like this clockwise. It is 10 multiplied by 4. Now 4, it is going to exert clockwise moment. So 4 multiplied by 3 is the moment of 4 Newton, right? This is according to the Varignons theorem, right? Now from here we will find the value of x. So let's first simplify this. Now 10 multiplied by 4 is 40. It is 40. Now 4 multiplied by 3 is 12. So it is 12. Now 40 plus 12 is how much? 52, right? So it is 52. Now from here we will find the value of x, right? It is 52. So what is going to be the value of x? It is 52, negative 52 divided by 15.62. Okay, so let me use the calculator. It is approximately negative 3.33, negative 3.33 centimeters, but we have a negative here, right? So x is negative 3.33 centimeter, right? But what does this mean? We have a negative here. Oh, we have a negative here. So what does it mean? You see, if x was 3.33 centimeter without this negative, then we would have say it is at a distance of 3.33 centimeter from point D. The resultant is at a point distance of 3.33 centimeter from point D, right? But we have a negative. Negative means it is exactly opposite. Okay, it means the resultant is somewhere here. Okay, it is 3.33 centimeter. Okay, so resultant is basically here. This is resultant, which is 15.62 kilonewton, right? And the angle with the horizontal was what? 39.8, which is at a distance, which is at an angle of 39.8 with the horizontal. Okay, so this point right here, it is the exact location of the resultant. Okay, so this way, using Varignons theorem, we find the exact location of this resultant. Okay, now I hope it's making sense, and if you have any doubts, please comment, and see you in the next class. Thank you.